Hello again, welcome back to another video. In this video we're going to be taking a look at these two integrals here. So 1 over 1 plus x squared, and then taking it a little bit further by doing the integral of 1 over a squared plus x squared, where a is a constant. I'll just write that down. And these are going to be really useful when I do a video on the integral of tan x dx, square root. So it's really important that you understand how to do these now. Let's get started. Now, we're going to be making use of a trig identity, and the trig identity we're using is this one. 1 plus tan squared theta equals sec squared theta, where theta is the angle. So make sure you know your identities. Right, we're also going to be using integration by substitution, so make sure you know how to do that as well. So we're going to say let x equals tan theta. Right, then dx by d theta is sec squared theta. So the differential of tan with respect to theta is sec squared. That's a basic result. And so dx equals sec squared theta d theta, like so. And now we can transform this integral. So let's go ahead and do that. So the integral of 1 over 1 plus x squared dx is equal to the integral, it's 1 over 1 plus x is tan theta, so x squared is tan squared theta. And now dx equals sec squared d theta, so our integral now looks like this. Now, this denominator, 1 plus tan squared, is nothing more than sec squared theta. That's just our identity. So we can take this further by saying this is equal to the integral of, well, sec squared theta over sec squared theta d theta. And of course they're just going to cancel. And so we're left with possibly the easiest integral, which is just 1 d theta, and this just equals theta plus c. But you might be thinking, well, what on earth is theta? Remember, x was tan theta, so theta is just tan inverse of x. And so our result for integral 1 is just tan inverse x plus c. Okay, great. Moving on to integral number 2. Okay, so this is integral number 2, and we're going to be making use of the result we just proved, which was 1 over 1 plus x squared dx is just tan inverse x plus c. So we're going to be making use of that. Right, let's have a look at this integral. The first thing we can do is divide everything by a squared. So this is the integral of 1 over a squared over a squared is 1, and x squared over a squared is just x over a all squared, like so. And it's still with respect to x. Right, how can we take this further? Well, we can take the 1 over a squared outside of the integral. And this is what we're left with. So this looks a little bit more familiar now. It's 1 over 1 plus something squared. And we know how to integrate that from above. So let's use another substitution. So let u equals x over a. Then du by dx equals, well, the differential of x over a is just 1 over a. And so in particular, this tells us that dx equals a times du. So plugging everything in by substitution, we get, well, the 1 over a squared is still there. We've got 1 plus 1 over u squared now, and we're timesing by a du, because that's dx. This a cancels with this a, and we are left with 1 over a. Right, the integral of 1 over 1 plus u squared du is nothing more than the inverse tan of u. And don't forget that plus c. Right, and the final step is just to plug u back in. So it's 1 over a tan inverse. Don't forget u was x over a plus c. And that is our answer. So that's the two integrals done. Hope you enjoyed. Bye bye.